And we're live. Hi, folks. This is Joachim from Brooklyn, New York, your host today for another session on the social ledger, next generation social ledger. I was thinking we continue the conversation from last time. So we shifted from a conceptual view towards a development environment discussion and then more towards an architecture discussion. So maybe we stick with that topic for a while, dive a little bit down into the architecture components. I'd like to hear more from you, John, what you think are the important components that we should take a look at next year. And we're still waiting from Jim, of course, who just came back from the conference in Seattle to recover and and follow up and all the other stuff that's happening. So we haven't made a decision yet on the web components and the web framework piece. Maybe that should be actually one of the bigger topics today, right? Let's go over this again now that we have Jim and you, John, both on the call. Let's make another deep dive on this. And thanks for sharing the link to the slides, John, and the code. I haven't installed that yet and tested it yet, but I will take another look at the code. So my thinking here is let's talk again about web components versus web frameworks and start to target some of the pieces, some of the components we actually need for this, right? So there's a database backend, there's a front end, there's a UI piece. What components are we envisioning here? We should take a look next. And then from there, if we have time, let's take a look at some of the data architecture. Just get a clearer understanding of what I think the architecture, this data structure looks like, right? And then a segue into some point starting to write some specs, right? What are actually the features and functions we're going to implement with the next generation social ledger? Does that make sense so far? Yes? No? Yeah? Okay. So I want to take a step back maybe because I want you guys, you, Jim, and John, take the microphone and just have another conversation on the notion of web components and web frameworks. Gary's here too. Hey, Gary. Thanks for joining. I was just going over the agenda, and today we're going to continue talking about sort of the overall architecture of the social ledger and revisiting our conversation we had around web components versus web frameworks and where we're going next year. And we have both Jim and John here, so they can give us an update, or we can sit back and listen to the conversation that you may have, John, about why web components and what are the important pieces to move this forward here, right? Because I feel a little bit stuck here, to be honest, because it's fairly new to me. So I don't know exactly how to proceed now. To say how do we move or shift from the conceptual to the specs towards an actual framework we can use for implementation, and invite other people to start working on some of the modules, right? So modularizing this stuff is an important piece. So I'll hand the microphone over to you guys, and you can talk about anything web components related, frameworks, why not, why. Let's do another dive, and you can repeat some of the slides you have shown us in the past, John, just to make some of the points.
My thrust was prevention of technical debt and deciding on a stack that would enable new developers to engage. So where we can break feature requirements into manageable, testable, discrete components, both on the back end but importantly on the front end, because that tends to be the challenge at the moment for finding developers that can do that efficiently and create nice cross browser compatible UI. My personal opinion is I'm against frameworks, full stop. I'm against frameworks on the back end. I'm against frameworks on the front end. I'm against frameworks that for mobile. There's more mobile frameworks than there are mobile phones. And it's as simple as that. It's not. I mentioned the notion of using a framework. You may be able to accelerate the time it takes to get an MVP out.
Yeah.
But that is often used as a sales pitch, and I would disagree with that. One thing I'm mindful of is not to say this is the way it should work, because it works for me and it works for colleagues I work with. I think I need to understand more who's got most time to contribute to this project, Social Ledger, because Joachim, you might find that you like Meteor. It fits with your mindset. You are more productive in Meteor than you are in anything else. And that justifies the use of that that stack. I think to use the word stack is useful because it goes from interface right down to operating system. I did catch the last video where I was cut off. We had an outage here in Cheshire. Unusual. The whole county was out. But I did catch the video, and there was a point where you did say that when you look at Meteor, for example, although it's well engineered, it's popular, it is in decline. That is, you must ask yourself, well, why is it in decline? Why would we opt today for a framework that is in decline? I mean, that's one argument, but it's a monolith. It is an isomorphic stack, and some of the productivity accelerators include the Apollo framework. And what you're doing there is you're creating graph queries that run really in the client. You specify this is the query I want to run. It then goes right through the stack. It hits the database, and then the result set comes back. Now, if you wanted to use that same functionality in an Android phone or in a different framework, you have to rebuild it again. So I know I'm paraphrasing what you said, but I often think building systems in layers, first of all, is more manageable. It's easier to test. It's easier to break the work up across a team. And also those things only need to be done once. So if you did create a REST framework, that REST framework could be used for anything, for bots, for mobile phones, for web browsers, for administrator panels, consoles. You get the gist. I think I'm laboring the point. But if it was all done through this isomorphic stack, it is tied in. Its DNA is part of Meteor, and that is the big risk. And all I'm doing is sharing some mistakes I've made in the past of doing that. So I just want to look back quickly, and then I'll let Jim jump in. I would try them. I would set a day or two aside when you're free and say, okay, let's create the canonical to-do list in Meteor. So set yourself up your development platform. I think you've already done this. I've looked in Mattermost. Then create a to-do list that actually writes to a database, whether it's Postgres, MongoDB, whatever you want. I mean, I should be able to pick a particular database and it should work against anything. And then create the to-do list, and then do the same in web components. Because in a community like this where we're giving our time away, we're volunteers, that's the correct phrase.
We're creative people.
We're creative and we're volunteers. We want to be able to enjoy what we're doing. So to be foisted with a framework that you don't like and you're not productive with is the worst of all cases. So I think that's the trade-off that I think we've got between technical debt and getting the job done.
Mm-hmm. Yeah, thanks, John, for the recap here. And I mean, I have to say, I haven't programmed in Meteor, right? The reason why I looked at Meteor is some of the patterns I see applying for the social ledger are there to a degree, right? And I could, of course, sit down now and try to write, some of the initial functionality using Meteor and see how far it can get. That's a possibility. And then you could write some code on the other side and see how far you can get with web components. But, I mean, it's a little bit of a detour here because I'd have to learn a lot more about Meteor before I have some solid code set that's ready for comparison with the stuff you've been doing on the web components side. To me, I'd rather understand that side better now, just so I can start recognizing some patterns we can actually use for the social ledger, right? And that's the usual stuff, that's dipping into a database to retrieve some data and then showing that on the front end. Parts and pieces of what you already shown in the demo last time, John, right? With the card-based interface that you put out there, and retrieving some data through query mechanism, and what was the goal, right, as a language you used there.
I mean, I'm not being reluctant here. If you want me to do a replay of the last demonstration where I did the demo rather than the slot, good. I'm glad.
No, enough of that.
I think we're all sold, hook, line, and sinker. I mean,
well, on the end condition and the requirement to be playing in those areas, certainly. But I'm also very aware that Joachim's got way down the track with the current work, and I really want to see this happen with what you got in hand, So it's sort of like, as a development framework, it seems to be very productive for you to express the ideas you're evolving here. So let's not get in the way of that fire hose, if I'm going to put it that way.
Well, right? I think it's up to you, Joachim. I think, I feel, and I think he feels that we've gone down that road far enough so that we can evaluate it, and we need to go down the other road a bit to evaluate that.
Well, but perhaps the thing there is the other road has to be sort of scoped out a little bit so that you don't have to cut your way through the brush. I mean,
That's what I feel. That's a good way to put it, Michael.
So, I don't know, John, it seems there's an opportunity to take this sort of some of the elementary feature sets in the stack that Joachim's put together and sort of mock those up in web components so that we get a measure of what's necessary to transit or to interface the two.
Let me have a think, but that parallel programming is a good idea because I've forgotten the thread of my thought now, but I think going down the prototype route has to happen.
Mm-hmm.
That has to, and it needs to start today.
Mm-hmm.
There's something I mentioned to somebody else. I think this is appropriate because none of us are getting any younger. And this is important because when I said before it was a kind of trick, because I've been doing this a long time. But when I said do the canonical to-do list in Meteor and then do it in web components, what you'll find is you don't like any of them because front-end development is so tedious, it's so time-consuming. You'll get something to work in Meteor or web components or React or Angular in Firefox and then you'll try and run it in Edge or Chrome, and it won't work. That's the tediousness of web development. And then you start to look at it in an iOS, iPad application, and problems trigger there. What I'm saying is, you pick I say framework. I don't like them, but it's not a showstopper for me. I wouldn't put money into a startup that was doing this, but we're not a startup. But
we have no money.
We have no money, so it's a false argument. But what I'm trying to do is, I've remembered what my thread was, so I'll come back to it in a minute. It's what I'm going to say now is to say that go with your gut feel, because by the time you've done the canonical to-do list in Meteor, I know I'm not going to judge you. I don't know you well enough. And I'd say that you're a good programmer anyway, but you will go through a learning curve that you probably expect to throw away. So it's the mentality of, well, why do that in the first place? If web components are the future, we have to go down that route anyway. So you start learning today, you go through that pain barrier, which there is one, or you call it a learning curve. There are other bits to web components I haven't covered yet, which I could cover on another week. But at the end of the day, we could just look at what I've done as just a slight detour, because if somebody else comes into the team a month down the line or 6 months down the line and say, why haven't you done this in web components? We're fully prepared to say, yes, we did a full assessment of this. We looked at it thoroughly and we chose to use Meteor because. Now, I think that's a good position to be in. We know why we made the tech. So we've covered the ground, whether we go with it or not. So that's an upside I see in this, if it's a distraction. What's up, Michael?
I hear you. It seems to me the first stage in that maybe would be an outline specification for the web component side that you would be best to sketch up, so that Joachim's got a sort of a comparison point so you can consider the process of going through that canonical creation.
Well, I can't.
Show us your canonical. You show us yours.
What I can do today is put my, because when I feel obliged, as I did do with the demonstration, I was so busy that week I could have done without it. But I felt, you've allowed me to have my say, so I thought I'm going to do this hell or high water. And I got it done, but it wasn't, I could have done a much better presentation. Everybody says that. But what I can say is once we start down the road on this, I could perhaps run in parallel and do a web component implementation or a mock-up or a prototype just to see where we get to. Because I think in the first stages of Meteor, you will be working on your own. We'll be able to come in and do testing and thrash out the functional and the technical requirements spec. But it's until the system starts to unfold a bit more and it gets into version control that you can get people to help. So that's the downside of using a framework. So I think we've got lots of options. So one is I will say, okay, well, I can see the specifications, so I could just run with those and say, well, here's a web component material design version. What do we think? And we can make another assessment. So I think that's a good position to be in. So we've got the best of both worlds.
I'd certainly like to participate in the web component side development. And I think there's some common development, or there may be common development from the side of backend. And I think GraphQL is a direction that we're looking at going, and I'm not sure exactly how this fits into web components here. It's mostly about the front end, but that's one area where we might want to go with Janus Graph using the Oracle Berkeley DB. And that allows us to even keep data in the browser, as well as link browser data to the server side with a single call. The Apollo client may fit in well with the architecture. That's sort of what I've been led to in my last couple of days exploration. I don't know, you want to give some feedback on that.
So, yeah, go ahead, John.
Just quickly on this topic, I can't go into too much detail because it's for a customer. So I can explain, well, we've been using Kaylee, which is, you might think I've got shares in Google, but I don't. But Kaylee's got lots of issues, but we're looking at and we're seriously considering putting into production now is dgraph. That is, I think I put it into Mattermost. I can come back to this at another time, but that's one worth looking at, Jim, for just interest. It is a really good, solid database, and it's one, it's almost, I get the same feel as Postgres. It just works. But we've hit a problem to do with calculations in it that are a bit lacking at the moment, so we may hold back for 6 months or a year. Now, going back to Apollo is self-contained. You could use Apollo in web components. It's not part of Meteor. And whether this is an appropriate question, but I'd like to understand the rationale of why do you need to use a graph database? Until you can explain that to me as a 9-year-old, treat me as the idiot in the room. At the moment, I don't understand why you need a graph database, because graph databases are good, are fantastic for a certain subset of queries and data, where good old-fashioned value, key value or relational databases can almost do everything else. And of course, you want no SQL. So that it's another place where there's so many options, but we've immediately hit a point where wouldn't it be nice to be able to swap out Janus Graph for dgraph? And I think Gary's got some insights into dgraph. I saw his post about a month ago in Mattermost. And the same with dgraph, you get a Go driver. And essentially what you can do is pull out of, we're using it for skill sets. So it's a map, huge, ginormous skill sets of particular job roles in IT. And with one query, you can pull out a nested JSON structure, which you can then plot in a graph. But it's essentially, it's one call to the database to get a huge graph result. If you can do the same thing in a relational database, but it'll probably take you about 20, 25 queries to build up that same JSON structure. So it's not, you can still do it in the same old relational database. It's just, it's convenience, it's shorthand to do the same job. where the graph database does come in is where it can discover relationships. So if that's the rationale for why you want to do it, well, you could say, okay, well, it can be done in other ways, but okay, there's the justification for it. So
yeah. So John, yeah.
My main justification is that the queries in GraphQL have a correspondence to terms in the process calculus, and that's if you want to say that's discovering relationships. It's also it's deeper than that. Although I still believe in being back-end agnostic, and see how a key value store, or what they're calling in the identity world now, index value stores, because keys mean something else. You know, we need to investigate how we can get data, back-end data, be back-end data agnostic when it comes to our GraphQL support, which I have to look into further. But in principle, we should be able to use GraphQL against an index value store. I see the Berkeley DB solution as being really fast, runs in the back end or the browser. If we only had to support one, I would say we should support that, and or that's my leaning. And maybe we need to make a requirements matrix to make a decision there.
Okay. Let me jump, Michael, yeah, if you want to say something.
Simple clarification, because I'm lost in all this space. My developer shifted us from MySQL to Couchbase, and then on to other non-SQL platforms. Does that have anything to do with what you guys are talking about? Non-SQL versus SQL?
Yes, it does. It does, Michael. So let me give you my. It does. You're right with us here. Let me give you my point of view. The stuff I see with the GraphQL stuff, I want to reserve that, sort of put it aside for all of the API stuff that we're building. Okay, that to me is what I can read and understand is the ideal way to interface with the different APIs we're faced with, right? The different applications that are out there, be that MetaMost type, be that a Walletback type, be that a Ghost type, whatever the application is out there. If we find a good way to interface with those and extract the API and extract the data and use that in our tool, that's the purpose of the GraphQL. I'm with you, John, in terms of a graph database. I don't see the need of storing our data into a graph database simply because we're not building a graph-like data structure. Our data is fairly flat. Let me show you. This is a good point to show you. This thing I wanted to show you 3 sessions ago. How I envision our data structure for the new version, right? So this is a layout here. It shows you, 3 different types of data. There's cards, there's context, and there's user, right? So simple as possible. And card has data around the card that's being displayed. Context is the context you're in and where the card is being displayed in, right? So be that Basecamp, for example, is one context. And you can say in the context of Basecamp, we're going to show 10 cards, right? And that's contained in this data structure. And then user, of course, is who you are, your credentials, whatever we want to store around the user, right? And what I very much prefer in this flat data structure is a NoSQL database. And the reason I'm saying this is because, you know, the current version of the social ledger runs on Firebase, right? Which I'm not sure if that's the best NoSQL database. You mentioned Couch. I heard good things about that too. But the data structure, as you can see it here, you know, is flat. So that means there's a card ID, you know, and then we have a listing of hundreds of cards, right? So there's a type, there's just sample fields here, right? So there's a type, there's a title for the card, and then there's some actions you can perform in the card, right? So in each action, that's again, there's a list here of, there's a name for it, there's a link that you can use, and some points you can assign to an action, right? So again, card, type, title, and then some actions, and then some tags too. So again, that's a list of tags, flat list of tags assigned to that specific card ID. And this card ID is the typical NoSQL thing where you have this long number sequence, right? That's auto-generated for you. That's unique, right? That lists all of the cards here. So this thing does not have any relationships, right? If you look at the user side, obviously same story, right? You have the user ID, and then you have type, name, and email, and an avatar thing, you know, the URL of the user, and then some tags too, right? So we could use a list of tags as a simple mechanism. Now I'm using that because it's a way to have some commonality across the data structures, right? So the tags around the user, that could be your speciality, your experience, whatever you want to you know, store in the tags here, versus tags that are around cards, right? So giving more contextual information around the card. But the important piece here is the context, right? So, and that's to me the same story here. There's a context ID, right? So every space, every place that we open has a context ID. And then this could be further expanded into a universal, you know, an address for that space. So I just listed one here as an example. Say ArtChain project, Social Ledger Lab, Basecamp as an address for that space. So, you know, more human readable address versus the ID that's being generated in NoSQL databases, right? And then it's as simple as, you know, okay, we have the context now, Basecamp has these cards, right? And that's a simple list again of, okay, here's the card ID, so the same card ID as over here, right? And then there's an owner to that, and there's some contributors to cards, right? And there are members who have certain access roles, right, to the space here, and to the functionality of the card. And then tags again at the bottom. So again, tags now meaning tags for the specific context. So be that Basecamp, so there could be some properties around Basecamp that we can store in this data structure. But it's all pretty flat to me, right? So, and, you know, going back to, you know, how would this look like in a relational context? You know, that's something like this here on the bottom left, where you have the entity for card, and you have entity for user, and then you have something like a context, this relational entity that combines them into some kind of an end-to-end relationship, right? So the classic entity relationship thing in a SQL kind of database, right? That to me, I really, you know, I've done this in the past, and I don't want to see this ever again, you know, to create any programs in relational databases. That's why I think the shift towards a NoSQL database here for flat data structures like this makes sense to me, right? And it does not, see, this thing here does not go as far as creating a tree-like structure, or say Facebook obviously has these social graphs, right? So that stores, as you mentioned, John, all of the relationships and properties across, you know how deep you want to go in this graph type database. And that to me doesn't even sort of exist in the social ledger, because the social ledger only stores information about the card, information about the user, and then information about the context where the cards are surfaced, right? And they can surface, you know, interesting aspect of this structure is they can surface in multiple places. It's not unique, you know. We have this graph type that allows, you know, to resurface endpoints in other spaces. So cards can reappear basically in multiple places. So you can just list them here. And it's an effective retrieval mechanism too, if I put it this way, right? So because you operate from context to context, you know, from space to space to space, and you need a fast way to get the information out, right? So you need a fast way to retrieve the 10 or 50 cards that are in that space, and you need the properties around the cards that you're taking out of this context here, right? And the users also, right? So the members that are associated with that space, and the members who are actually contributors to this card inside this space, right? That's important because as cards can reappear in other spaces, you have a different set of contributors. But that to me is an easy and efficient mechanism. You know, keep it flat, and then you can pull in this data very, you know, fast, you know, by using these three, call it entities, right? So the user, the context, and the card. I'll stop here. Yeah, John, go ahead.
Remember, I'm the dunce in the room. So if I ask a question that seems stupid, well, you say that, I won't be offended. But what I'm looking at here is what I deal with every day. And there's so many different ways that you can do this that you don't need a NoSQL database. What that result to me looks like is a join, a SQL join, that's been marshaled as JSON. It's exactly the same thing. So my question, simplistic question is, if you're only dealing with JSON structures, why do you need why are you considering GraphQL?
You mean not considering GraphQL? This would, I consider NoSQL, right? This would be stored in a NoSQL, just like it's stored in Firebase right now. You know, it's a similar set of properties, right? The user, the card, and the context is stored in a NoSQL database.
That Jim clarified before that GraphQL might be useful for a migration to Rolang, an R-chain.
You know, I'm sort of looking at this at a higher level, where every social object has a decentralized identifier, which I guess would correspond to the address he has here for in the context, but would be applied to every social object, and it would be for service discovery. In order to decentralize the system, allow for self-sovereign functionality to be represented in the system, and I see this as a structure that, you know, forms a graph. Well, it's a network where there would be many links between the social objects, which we would want to query against in many different ways. I mean, I still have, you know, it seems like if we're going to use the paradigm of GraphQL for API integration, that we should embody that in a more basic nature at, you know, the level just above the storage layer, so that where we use it for access and update. We use the GraphQL for both access and update of our data structures. It's a single mechanism that we have to learn. Um, and ultimately, it can be, completely back-end agnostic and be accessing external APIs as necessary.
Yeah, I like the last part you said, Jim, about using it for the API integration. But I want to get to you, John, first before I respond to that. You had a question.
So what I'm looking at on this slide now looks like standard output from any database. It doesn't need to be relational or NoSQL or any other graph database. That is what I would see coming to the browser, that structure. And if you're using say Postgres, so I've got a reputation for being a Postgres zealot. So I'll put that out there. But Postgres these days can act as a relational database, so it's useful for transactions. So we're going to have at some point a wallet where we need to be able to, I need transactional concurrency, so take money from here and put it to there, which you can't really do in a NoSQL database. So that's what they were not designed to do. But it can also store JSON, so it can mimic MongoDB or CouchDB. So you get the best of both worlds. You can either use it as a NoSQL database for storing JSON and querying JSON, or you can use it as a transactional database for financial or anything else where you need ACID compliance. So I'm trying to understand the rationale for using GraphQL. GraphQL to me is for discovering relationships, and I think you've already said this, Joachim, that you don't see that in the social ledger. So my question is, where's the justification for Apollo? Why would you need it?
Okay, yeah, let me try to rephrase that a bit. So what we do with the APIs, this is a gigantic data source we're tapping into, right? If you just take, let's say, Mattermost as one example, right? If you look at that API, you can achieve hundreds of thousands of data points, right? Even our little community now has, I don't know, over 100,000 data points in terms of the different posts, the different comments, the different likes, the different users, the different rights they have, hundreds and thousands of data points, right? We don't need that stuff in the social ledger. What we do need in the social ledger is certain specific data points that relate to what you want to see and use the logic upon. So when I say data points, let's say something like title, right? So we do want to see a title. Maybe that's the name of the channel, a corresponding channel in Mattermost, right? So that's the only data point I would like to retrieve out of Mattermost, the API there, and sync that with the card title, right? So ideally, you can make a change on the title on the card, and then it changes through the API, it changes the title of the channel, right? Or vice versa, you change the title of the channel in Mattermost, and it changes and update the title property here on the card, right? But to me, what I see as the GraphQL piece is a filter and standardization mechanism to say, all of these millions of data points that we don't care, we want to have a standard way to access those and bring in some of these points into our environment, right? Into our database. And since our database is fairly flat here, right? And we don't store so much data elements here, we don't need to have an elaborate graph kind of database in here. And the other point, John, I hear you saying you prefer a SQL database of a relational database structure. I went away from this a long time ago because of the flexibility you get with programming in a NoSQL environment. These properties that you see here, they're here today. Tomorrow, they're going to change, okay? There'll be 10 other properties. In a NoSQL environment, I can do this. There's no, to use your term, technical debt, right? That I have to go and rewrite my SQL queries everywhere I've used them in the past, right? I just add it and then may have to make some modifications, I can still use it, right? So the flexibility you see on single level, and you see it goes deeper, right? There can be a nested structure inside this data element that goes 1 or 2 levels down, right? I can change that on the fly almost, right? And it doesn't hurt anyone if we do this. This is not possible in SQL.
It is. You have JSON data types. So if you've got a card variable that you know is going to is immutable, it's going to change over time. So you're going to add and remove attributes. You just have a JSON field. And with regard to when you change, I hope I don't sound I want the best for the collective, and I'm trying to be economical in getting the message across. But I feel as that I should maybe bring you up to date on what's available just with basic databases. Now, if you were to change, if you go back to what I was saying about software engineering and continuous integration, if you were to add a field in the normal relational database design, so we go back to the 1970s where it's fixed relational algebra, so we need to add in a new title, or we need to actually make the length of the title longer, so from 100 chars to 200 chars, that's a common thing. Well, in the build process, you call that a migration. So you'd actually rebuild the database as you put your code live,
right.
Including mapping the data across. So that's fixed as well. But if you know ahead of time that the context schema there, that's going to be in flux because we can't predict what the future is. Well, you make that. There's 2 types in Postgres. There's JSON, which is the text format, but there's also Bison, which is a binary version, which is high performant, and it also compresses the amount of information that you've got. So one thing I would say is, and this bears fruit in our research, that MongoDB really is legacy. You don't need MongoDB anymore. Postgres can do that, and most modern don't mention MySQL, but other databases can cope with this. But even if it was in a relational database, say we need a list of emails and we need a list of usernames. So you can't quite do that in NoSQL. But if you wanted to go down that route, well, this is what the output of your system requires. In the middle, you can have an object mapper, which is quite common as well. So you just ask the database, I want this user that's connected to this context, is connected to this set of cards. Go and get me the whole, and it will create the query for you and send back the JSON. And it's still using a relational database on the side. So I totally appreciate what you're saying, that the NoSQL provides you with a huge amount of flexibility. And that's really useful in a system where you don't know what the requirements are up front, but it is also very useful during the development process, to be able to quickly change schemas as you're developing things. But I think that isn't an issue anymore. It's been fixed. We use Postgres, so I'm as I say, I'm blinkered and I'm a zealot. You can call me that, but it wouldn't be. You could use Postgres for everything, even graph stuff. You put a layer on top. So at the moment, I see this as quite an easy project. It's not going to be difficult to do, is it? I think where the difficulty is satisfying your requirements for a beautiful front end that's very slick.
Okay, that's great, John. I mean, that opens just another pathway to say, hey, maybe the database backend does not have to be, something like NoSQL. Maybe, as you said, Postgres can handle. I haven't looked into that, to be honest, and I can see, of course, they evolve too and can handle JSON queries as well.
So if agnostic means not knowing, then I'm agnostic between my back end and a hole in the ground. So I don't know what earth this has all got to do with the possibilities, except to open them out. I'm hearing that everything can be fitted to everything else. We don't have to worry about it. Go for it. Am I right?
Well, you know, you have to consider how elastic the system is and scalable. What it's going to take to manage it. Um, I love Postgres, but it doesn't seem to me management of it is simple. I'm not sure that Couch is any better or Janus DB.
Janus is a graph database, isn't it?
Yeah. You know, I still have a leaning that way. You know, the eventually consistent state information that you will want to keep about our social objects, I see as being a little more malleable than what's here, and I see that the access to it more graph oriented, and having it in the GraphDB to begin with may be profitable, you know, in terms of using the data later. I'm not sold either way, and I'm also agnostic to a large extent.
So what I'm hearing is that the kernel of what the social ledger architecture is about, the thing that it's meant to do, can be handled on Postgres. It can be going non-SQL, whatever. So that's not really, that's a choice and development decision. But the stuff that's got to be put together doesn't really care which end it's working from. Is that true?
I think so, Michael. We can say that, and if I mean the common baseline here, I think we all agree on is we're gonna use JSON as our data structure. It goes in and out, you know, and the data is being displayed through these data structures, these examples that you see on the screen here, and whether it's stored in a SQL database, in a relational database, or NoSQL, I'm indifferent to. I'm with Jim there too. You know, if that can be handled as efficiently or even better than in classic NoSQL databases, then it's certainly a route we should explore.
So we seem to have a great and common indifference about this. We're all indifferent to the database.
I think this is a good session, though. It's just as a sounding board, just a bounce experience of what people have used in the past. Now, at the moment, in my business, we use Postgres. But if you go back 5 years, we were dumb enough to be using SQL Server, because that's when how the business started with. So a huge pile of technical debt trying to extract ourselves from SQL Server and all our partners. So when you think it's only us that has to change, it's no, all your partners have to change as well, because they're using SQL Server, or used to do. But our main data warehouse is 4.5 terabytes in size. That is ginormous. That has to be indexed, but it's there in Postgres in a relational format for calculations in order to run salary benchmarks and discover skill sets, etc. Now we're bringing in graph databases, so we use Kaylee at the moment, and we're thinking about using this dgraph, which I've posted into chat, but that's more of an analysis engine. So the transactional stuff, all the sample data that we obtain from all over the UK is in a secure, flexible platform, what I call Postgres. So it's easy to query, it's easy to back up, it's easy to restore, it's easy to shift around all the cloud providers as well. But that's my question about GraphQL. I see it not as a tool to do your operational work with. It's a tool to do research or analysis. So you still have to have the core database. And what I like about GraphQL is the speed it can import all that data. So Cayley, if we do say, go back to 2010 job data in the UK, when we're importing into Cayley, it takes 2 weeks. It's that slow. You have to sit on the server and let it run. The dgraph, it's all written in Go, can do it in about 4 hours. But we're only using it because it's there. We've got the data, and it's there just to give us a more efficient way to query the data in a slightly different. It's shorthand. In fact, it's going back to what I was saying before. It's syntactic sugar. Graph databases there are 2 types. One is better for discovery, and one is better for performance. And I can't remember which one. The difference between the two, and we've always used the same type. So I would, my mantra in life is to keep it simple. There's a huge amount that Postgres, and you might think, I'm just using this as an example. I'm not sitting here preaching that you must use Postgres. I can work with any database, and I enjoy experience of a variety of them. But when you pick one, if you go for Couchbase, and you hit a problem, you're not going to be able to solve it as quickly as you can with Postgres. The Postgres community is ginormous, and it's getting bigger. So when you hit the problem where, why is this index corrupting? Or how do I get this function to return a table instead of a value? You hit Stack Overflow, and the answers are there. And the other thing I would consider as well is just perhaps another session on this, is to step back and say, well, what's our budget? How much can we afford? My advisor is asking us to actually switch to managed services, but you have to pay for all this, and it's not cheap. When you start using databases, the prices really go up. It's okay when you're using certain serverless stuff. That's quite cheap at the moment. So my business, they are virtual machines, but we look after Postgres. I'm so used now I change Postgres and recompile it just so it works with our data. So I disagree with Jim. Postgres is easy to use, but in this environment, you may say, well, we don't want to get our hands dirty. We just want a system like we've got at the moment, which is Google Firebase, which is backed up, it's patched, everything is done for us. We just have to pay that recurring monthly fee plus the usage charges. And it could be that, okay, so if there's a budget in DigLife for this, maybe we should be looking at going with the next version of, I know it's still in beta, it's not called Firebase, it's called similar name, it's in beta now.
Right.
So it's should we be looking at, so my point I'm trying to make is, okay, we've got all these open source solutions, Couchbase, MongoDB, Postgres, the list is ginormous. We would never use MySQL. That's a bad idea. But then, we want to be able to move towards decentralized, whether it's Holochain or R-Chain or anything else. That's what attracts me to this collective. I don't know how it's going to work. I don't know how how things are going to fit together. I don't know how you're going to build systems in it, but it's fascinating, and that's where we want to go. But in the meantime, we've got a problem to solve, and it's whether we go down the basic route or we should be using hosted services. So there's a plethora on AWS. Google provide a pile of different databases. There's probably options in Cloudron, which are managed services. And Social Ledger at the moment is using Google managed services. So that's like a fork in the road, whether we go down that route or we stick with the route I'm more experienced and familiar with, which in a way, is the bad route. It's the route that you shouldn't go down anyway. It's risky. It requires people with experience and time. You know, I'm stating the obvious now, but I hope everybody gets that. Jim?
I gotta go. I forgot about my meeting.
What's the time? Oh, past 1 o'clock. Good. So I think, let's get back, and if you can share some links on Postgres, and how do you handle JSON data structures, in a Postgres environment. I'd be curious to learn more about that. That's simple enough, for us, because all we do here is really just shuffling in and out JSON data. Use that to present and to build the logic of the front end and the JSON that I want to extract out of the API integrations, and storing partial set data sets into our database. Then that's worth to explore, I think.
Well, I think that is an option for a managed service as well. So it's available it's in beta in Google, but in AWS you can get a managed Postgres instance, and they're quite cheap. They're $16 a month, the small ones, which would probably suit SL2 for the duration at the moment. Am I making sense here? I feel like I'm waffling. What I'm saying is Postgres is available as self-installed, self-managed, but it's also available as a managed service in addition to Firebase and et al.
Right. So the self-installed version, is that open source? Is that free?
Well, yes. You just do a yum or a apt-get, apt-install. That's what we do. Mainly do that, but as I was saying before Jim left, for the collective, it may be a bad idea to do that. Maybe we take the hit and just get an instance on whatever cloud provider. I'm agnostic to that. But all the patching and the backup and the security is all taken care of for you. We then concentrate on development. So we could have a development instance, production instance, and maybe a staging instance.
Yes, and things like those subscription or paid services that you adopt now can easily be swapped out later for our own instance, which may require a lot of development time, which could be better put off until we've got other things going and more interest in the project.
Hmm.
So it's always cheaper to do it yourself, but it's not the way to go. I mean, my advisor tells me if you're trying to create a company with an exit strategy, you need to be in the cloud, and it all needs to be self-managed, because if a company looks at you and says, well, this is all manual, there's a reason they won't purchase the company. So for Social Ledger, if you want to encourage other communities to adopt the system, if we just say you just sign up to this database with cloud provider A, that's the end of the story. It's $8 a month and that's it. Maybe backups, secondary backups to do. But I'll be interested, I'll enjoy rooting out what I can for you on Postgres. And if Gary, if you're interested as well, I'll dump it in Mattermost.
Well, I'll be honest. You said that you're the dunce in this group. Then I must be in the wrong place, because I feel like you're all experts here, and I just read stuff and occasionally find something that looks interesting and put links in the channel. I like the dgraph database because it was both graph and distributed, rather than letting somebody else handle the distribution for you. But I'm way over my head most of the time here. I've got so much technical debt that I'll never catch up.
Everybody feels like that here, Gary, right? Because we're exploring so many different areas. We're not familiar with this. So yeah, let's proceed on this and explore another route here. That's what I see today here is yet another route that's opening up that we need to explore. on the database side now. We haven't even started to talk about the front end and how is that going to look like and what tools we're going to use here. Right?
I think that's where the work will be. I think that's the challenge.
Yeah.
My feeling is the expectations would be for an interface that is high quality and looks good. I think your standards are very high, Joachim, and it's been able to meet those standards. Where I think that the database and where we run it and even our workflow is going to be really simple. I think I'm quite confident about that. And it's picking the tools that you are most comfortable with. All my colleagues are comfortable with Postgres because it's so damn flexible. And that's where it becomes a platform instead of a framework. So MongoDB can only do JSON. So if we could find an environment where we possibly do need the best of both worlds, and it can run Python, and it can run, so you can do things that you can bend it in all sorts of different shapes to fit the purpose. And it also has messaging and stuff like that. So you can pass it messages and you can have other clients that listen to that. There's one other thing I want to ping over. I'll stop talking now because I know I send people to sleep, but there's something that cropped up today I know that WebSockets is the way you want to go. I mean, that's another question I could have, that why are we going for GraphQL or why are we using WebSockets? But I just want to show you this as an example of how it could be done in serverless. There was a time where they said that WebSockets could never go on serverless. Well, somebody's fixed it now. It's all been done. And the problem that you'll find with WebSockets is it doesn't scale. Although Google can make it scale behind the scenes, if you were to pull the curtains back and have a look, they're just using tricks. So there's WebSockets also can't go through load balancers. So load balancers you may think of as something that helps with massive scale. Well, load balancers really help you get your job done. You can point it to one server. If that server goes down, you use the load balancer to switch it to something else. It also acts as the firewall. So you can only let port 80 traffic through it. You can also offload SSL, and it can also handle HTTP too. So really, load balancers is another word for proxy. You know, it's what protects your back end from the internet. So as far as I know at the moment, AWS, I don't know with Cloudrun, I don't even know if Cloudrun has things like that. But you can't use WebSockets, that's the problem. But it could be that one thing we should look at as well to keep prices down and to make the workflow more inclusive. That's what I'm trying to do. That's what I'm talking about, is how do you make the whole thing more inclusive so you can get more volunteers involved? Is looking at this serverless malarkey, and I'll post this in Mattermost. So I wanted to be quick in what I said then, and I've waffled on, but I'm quite excited about this because it is going to be a game changer.
And and you mentioned that earlier, John. I remember you talked about that. Please share more of this. And
so I'll try and find the best of. No, I better not do that. You want to look at JSON only. So if I just concentrate on that for now, find out, and then I'll put this WebSocket. It's called Grip, the tool, and also AWS last night launched their repository. So I'll send a link to that. So this is now where you can go and look in the repository for anything, so it's a bit like NPM, but for serverless. And what I know AWS is where we don't want to go. So I'm just raising this as something to look at and gauge where the rest of the industry is going. But in order to get into the repository, you have to be open source. So your code has to include an open source license, or a number of them before AWS allow you in. So there's a lot of people today saying, well, what's the point in that? How are we going to monetize ourselves? But what Amazon is saying is, well, you monetize your things. So you put your glue in a discoverable repository, people find that glue, and then they realize, oh, we need to pay for that. So this is where we could have, thinking about social ledger, people discover bits of social ledger in the repository there. That leads us to DigLife. So everything has to be open source. You pick what you want, it's all automatically installed for you, and off you go. And this repository is huge. People piling code in there at the moment. So whatever people's thoughts are on AWS, I'm ambivalent, I think, at the moment. I'm not sure where things are going. But they seem to, they seem to be good at this flywheel, where the bigger they get, the more they pile back into their development. That's the repository. I'm Jason.
Yeah, this is the same sort of thing that the Subutai space offers on a very much smaller level, of being able to distribute out and handle the loads. And they've got their repository equivalent, where open source components can be dropped into their container set, and you install it and you can monetize in that framework too. So this seems to be the game: give it away and monetize it.
Good. All right. Let's wrap up for today. There was a lot of good conversation. Thank you. A lot of divergence. I like that, looking at different paths ahead. I do like to come back to, a convergence track where we do agree on a limited set of tools and ways of working together, right? Because to me, it's important to sort of limit the frame we're working in. I don't want to make it too big, because then it's hard to, see what's happening and bring more people on board. If it's a limited set of good, solid feature that we've done our homework on, that to me much easier to share. If we agree on certain bits and pieces here together.
Excellent.
All right, thanks, guys.
Thank you.
See you for another round.
Thank you.
Take care. Bye bye.